Welcome, everybody, to my Linux show. I am the Model Citizen, and in this video, I'm going to be showing you how I build a custom graphical desktop in Linux on my PlayStation 3, running Fedora PowerPC Linux. I'm going to switch over to my PlayStation 3 really quick, just so you can see. Okay. This is what's on my PS3 right now. I know it doesn't look like much. It's just a Linux login screen. At the moment, I do not have a graphical desktop environment installed yet on this PlayStation 3. Now I know it doesn't look very busy. I know that looks like it's not really doing much of anything right now, but let me show you something. Looks can be deceiving. I switch over to my TTY2, my Virtual Console 2. This is what my PlayStation 3 is actually doing right now. What you're seeing here is I'm compiling GCC version 9.5.0. I'm using GCC version 4.4.4 to do the build. And in case you didn't know, GCC is one of the largest projects that you'll ever build from source in Linux or on any operating system, I guess. It's a huge project. I think the archive that I downloaded for GCC 9.5.0, I think it was like 112 megabytes, which is gargantuan when you consider that it's just all source code. So yeah, that's what the PlayStation 3 is actually doing at the moment. It's building GCC. It's doing that in the background. I've also got HTOP running here on my console, just so I can monitor my system processes and stuff like that. Now, this build procedure that I've got going on right here, I fully expect this build to continue on well into tomorrow, or possibly longer. Yeah, GCC is a very large, a very large project to build. So we're just gonna let this continue doing what it's doing, and I'm gonna switch back over to the TTY1. There. Okay, now if I wanted to, I could actually log in here and do all my work here from this virtual console for building our desktop environment, but it's kind of boring looking at a black screen for extended amounts of time. So what I'm gonna do instead, check this out. I'm gonna switch back over to my laptop. Right here, this is where I'm doing my recording for this video. And we're going to do our build procedure remotely over an SSH connection. Make that a little bit bigger. Okay. Okay, yeah, so I'm going to SSH and log in to my PlayStation 3 over the network. Okay, we're now logged into the PlayStation 3. There's my CPU info in case you don't believe me. That yes, this is a true blue genuine PS3 game console that we're working with. Okay, so the desktop environment, well, can't really call it a desktop environment. The GUI desktop that we're going to be putting together is going to consist of basically four packages we need to build. There's four packages that I normally build to get my graphical desktop up and running. Let me show you my source code directory. This is where I keep source code archives. So all the ones that you see here, these are all these are mostly all source code archives of applications that I like to build on my PlayStation 3. And the ones that we're going to be working with today are this one here, Openbox. Openbox is a window manager. It's the window manager that I like to use on the PlayStation 3. It's very minimal, very lightweight, and yeah, it's a excellent graphical desktop window manager for the PS3. So we're going to build that one. We're also going to build one called Tint 2, this one right here. And what that is the this is a panel that goes at the bottom of the screen, kind of like the one that's on the bottom of my screen right now, except a little bit different. This is XFCE I'm using here on my laptop today. I'm using the XFCE desktop environment, and yeah, this is the XFCE panel at the bottom. So instead we're going to be building the Tint 2 panel, which is a very nice panel to use on your desktop. Another one that we're going to build is this one, Openbox XDG menu. What that is a menu generator. See, in Openbox, your applications menu is accessed by right-clicking, basically anywhere on the desktop, or you can do it by clicking on the panel at the bottom. Yeah, right-clicking brings up your applications menu, and that's how you run. That's generally how you run applications when you're in Openbox. Now the thing is about the Openbox's menu, it's defined by a XML file called menu.xml, and that's the file that you edit to change your entries that are on your right-click menu. But if you don't want to have to, if you don't want to have to like enter all of your programs in manually one by one on your and create the menu that way, then what you're going to want to do is use one of these. This is a automatic menu generator. I'll show you how I implement how I implement it in my setup. Last but not least, we're also going to build this nitrogen. This is a GTK GUI program, and what this does is it sets your wallpaper. It sets your background. And it works really good with Openbox. So yeah, those are the 4 packages that we're going to be building, or the 4 tarballs that we're going to be building in this video. And I guess the first one that I generally like to build is the window manager, the Openbox window manager. So I'm going to open up that archive. Openbox 3.6.1. This is the latest and greatest version of the Openbox window manager. The newest version that I could find, the newest one that's available. If you compare it with the Openbox that is available from the Fedora 12 repositories, let me show you. This command will display the information about Openbox, the one that's provided by the distribution. See, the version number here is 3.4.11.2. So this version here, the one that's shipped with Fedora 12, is a little bit older than the one that we're going to be building from source. That's one of the one of the main reasons why you might want to build software from the source code is to be able to use a version of the program that is not available from your distribution. Like if you want to be on a newer bleeding edge version of the application, then one solution is to build it yourself from the source code. So I'm going to show you how to do that. Let me switch to my Openbox directory here. See, there's a directory here, Openbox 3.6.1. That's because this directory is what was inside this archive. So I'm going to switch to that new directory, and there's all the files that are in the directory. It has a script here called configure, and that's the one that we're going to run. We're going to pass it the help option. Now, for the actual configure string, the first option that I always pick is prefix. I'm going to set that to /USR. /local. This is the top level directory where we want our software to be installed after we're done building it. And that's what this directory is here for on Linux distributions. Your /usr/local directory, that's basically the whole reason that's there is so that if you want to build your own software or install your own software from some other some other place, or if you want to build it yourself, then that's the directory that you are going to want to install it into, /usr/local. Let's see, most of these build options here that they're giving us, we can ignore most of them because they all have like defaults, and like if you don't tell the configure script exactly where to look for some certain file or library or whatever, it's got a list of places where it'll search by default, and 99% of the time the configure script is smart enough to find all the resources that it needs on your system without any help from you. But of course, I like to make things a little bit more difficult for myself. I like to kind of micromanage my configuration. So I'm going to set a few of these options. Got another one, X libraries. And those are in /usr/lib. Let's see what else. Let's see, disable feature, enable silent rules, strict ANSI. Yeah, most of these things we can ignore. Let's see, shared and static, it's going to build both of those types of libraries by default, so that's good. I'm going to disable NLS. I always disable NLS whenever I'm given the option to do so. It's because I don't need to have like error messages in any other language other than English. NLS is native language support. So yeah, since I only use English, it's kind of useless for me. Now I'm actually going to disable startup notification because I don't really find it that useful. It's kind of a little bit of bloat in the application. So one of the nice things about building software from the source code is that if there's any functionality that you're not going to use or that you don't need, you can generally, you're given the option to strip it out, and that's going to give you a smaller binary that performs better, usually. Let's see. I'm also going to disable Xinorama because that is for machines with more than one monitor or multiple monitors, and the PlayStation 3 only uses one monitor, so we don't need Xinorama. See, LD is our linker. And set the system root. And X is our windowing system. or our Windows server. And all of these last options here that are all in caps, those are like environment variables that you can pass to the build procedure. Some of these I already have set in my bash profiles, or my bash profile file. I'm gonna set this one though. Whoops. Okay, I'm gonna set this to /usr/bin/xmkmf. Okay, that looks like a good configuration command. So yeah, let's go ahead and run this and see if the configuration is successful. It should be successful. I've already installed pretty much all of the dependencies that I can think of that are required for me to be able to build these packages, or to build these applications. So I shouldn't run into any issues, and these builds should go nice and smooth. Okay, configuration is complete. That's good. Now it's telling us that we can run make, so that's what we're gonna do. Run make, and I'm gonna pass it the J2 option, and it's gonna tell it to do a parallel build. Basically, do 2 jobs at once during the build procedure. It should speed things up a little bit. Now, keep in mind that the PlayStation 3 is currently still working on building the GCC toolchain. So yeah, the PlayStation 3 is extremely busy right now. So this build procedure is going to be affected a little bit. It's going to go a little bit slower than it normally would, but when I started the GCC build, I set it so that its priority, its nice value, is set to 10, I think, which should allow the GCC build to run in the background without affecting the rest of my system too much. Without slowing down my system too much and making it like unusable. It seems to be working just fine. This Openbox build is moving along quite nicely. Yeah, Openbox is not a very large project. It's not a very large program. So the build procedure is it generally doesn't take more than a few minutes. So it might take a little bit longer since the PlayStation 3 is also working on, you know, other tasks, but it's not being slowed down that much. This will be finished in like a minute or two. Now, I forgot to mention the other really cool thing, like the other really nice thing that you can do when you build your own software from the source code, is you can apply like optimization, like optimization flags to the compiler, so that it'll optimize to build specifically for your hardware that you're running on a PlayStation 3, which is a very exotic platform, very exotic hardware. It makes a big difference when you compile software specifically for your device, for your platform. The software that you build runs much better than the software that you could download from your distribution. Anyway, Openbox is finished building, so now I'm going to run sudo make install. And what that does is it will install the files that it just built, and it will install them in the under the directory that I defined with the prefix option. Alrighty, Openbox is finished installing. Now, since we did build shared libraries, gonna want to run sudo ldconfig, and what that does is it updates your linker database, basically, so that it, anytime you build new shared libraries on your system, and you want them to be available to use for other programs, for all your other programs, then yeah, you're gonna want to make sure to run ldconfig after you do the installation, because that will update your linker so that it's aware of your new shared libraries, and it can link to them. Okay. Now what I think I'm going to do is I'm going to save that configure string. Here's what I normally do. I'm going to type echo and put this configure string in parentheses or quotes. And we're going to send it to a file called Openbox 3.6.1.ps3conf. There we go. Now if I read that file, or if I dump the contents of that file, okay, there it is. It contains the configure string that I used just now to build Openbox. So now I've got that saved, because that's a good configure string. All right, we can back out of this directory and delete the Openbox directory because we're finished with it. I'm going to move the Openbox archive and the PS3 conf file. I'm going to move them both to another directory called installed. That's how I keep track of what I've already installed on my system and what I haven't installed yet. Here, let me show you the contents of installed. These are all the packages, or all the applications that I've already built and installed onto my system. A lot of these are the latest and greatest options that are available, like bzip2, gzip is latest and greatest, libevent. I had to build that because I wanted to build the latest and greatest tmux, and tmux depends on libevent. LZ4, that's a compression library. There's Openbox, that's what we just built. Here, these are very important: OpenSSH and OpenSSL. OpenSSH here depends on OpenSSL. OpenSSL is a crypto library for all of your cryptographic needs. It's almost impossible to communicate with any device over the internet without OpenSSL, because OpenSSL encrypts your internet traffic. And then here, OpenSSH 9.3 P1. As far as I know, this is the latest and greatest OpenSSH. There may be a newer one now, but when I downloaded this, like not too long ago, this was the newest version of OpenSSH. This is what I'm using to log in to my PS3 over the network. So I'm using this right now, as a matter of fact. Okay. I'm ready to build my next application for my GUI desktop. Let's build this one, Openbox XTG menu. Okay, I opened up the archive. Now there's a new directory here, so let's go into that directory. Now, this particular application is extremely simple. There's almost nothing to it. It's just a C source file, and this one here, this looks like a man page. And here is the make file that contains the information on how to build this source file. I'm going to edit this make file because I don't like the options the way that they are. So let's see. See here, look at this weird thing. The C flags that are defined, there's one here, hyphen G, and it's followed by another one, hyphen O2. These are opposites. These kind of like cancel each other out, or I think the O2 cancels out the G. It doesn't. To the best of my knowledge, as far as I know, I mean, I could be wrong. You know, I'm not a GCC expert, but as far as I know, when you set a optimization level on your GCC build, it invalidates the G option, which inserts like symbols into the executable to make it easier to debug. basically there's the G option is for a debug build, and the O2 option is for a release build, and that just doesn't make any sense to me. So I'm gonna delete that G option, and I'm also gonna delete the OS and change this O2 to O3 because I want a higher level of optimization. And I'm going to add some other C flags that are specific for the cell broadband engine. There we are. Those are some optimizations for the cell CPU. Let's see. Yeah, basically what this tells the compiler is the type of architecture that it's building for, with the mCPU and the mTune options. And these other three options, mNoString, mNoUpdate, and mNoMultiple. What those do, those are very low level like control instructions. What they do is they tell the compiler to write code that avoids using certain assembler instructions on the cell broadband engine. There are certain assembler instructions that are very expensive. They're kind of like composites. They have to be decomposed into simpler instructions, and doing that takes a penalty you pay in clock cycles. So we want to avoid using those types of assembler instructions if at all possible, and that's what these options do: mNoString, mNoUpdate, and mNoMultiple. Anyway, all right. So that should be good for our C flags. Now, there's no configure script here. We're just gonna, since there's a make file here, we're just gonna run make. And there it is. That's finished. That's all there is to it. Our menu generator is compiled. Here it is. This is the executable that we just built. Now, since there's no install script, we have to install it onto the system manually. So to do that, I'm going to do sudo copy Openbox XTG menu. Now we're not gonna put this with the rest of our binaries on the system, since this isn't really like a binary that it's not like a traditional program that you run from like the command line. This binary is generally accessed by other programs, so we're gonna put it in a special folder. It's gonna be /usr /local /libexec. That's where that's gonna live. Okay, that's our menu generator. And while I'm at it, I'm actually going to also copy the man page file, this one, Openbox XTG menu _1, and we're going to put that with the rest of the man pages of that type. It's going to go in /usr/local/share. /man/man1. Now if I run man Openbox XDG menu, it should bring up the man page. Wow, that was very slow. My PS3 must be very busy building building GCC in the background. Anyway, yeah, so there we go. Our manual page works. Okay, we're finished with our menu generator. Openbox XTG menu. We can delete this directory now. Okay, we're halfway there. We've built 2 of our applications that we're going to build in this video. We've got 2 more to go. The next one I think I'm going to build is the panel that's going to go at the bottom of the screen. It's this one here, Tint 2. So I'm going to open up that archive. And here is the new directory that was inside the archive, so let's change to that directory. Now, the Tint2 project uses a different kind of build system. It uses something called CMake. Instead of the auto tools that most other programs use. I'm actually not a huge fan of the CMake build system. I think Auto Tools is better. I think it's more it's easier to customize your builds, and it's more straightforward. But anyway, there's a file here called CMake lists. We're gonna edit that file to configure how Tint2 is going to be built. Okay. Now here, these options here, we can turn certain ones on and off. Since we're building for a PlayStation 3 and it's not like a laptop, it doesn't run off battery. We can turn off that functionality from Tint2. We don't need it. So we're not going to get a battery status area on our panel. Let's see, I definitely want Tint2 conf, so I'm going to keep that on. I do not need the Tint2 RC examples. I've got my own Tint2 RC file backed up that I like to use, and I'll be using that one, so I don't need the examples. RSVG, and here, this one's startup notification. Turn that off. Basically, if you leave that on, it's going to give you nothing but headaches. It's possible to do the Tint2 build with startup notifications turned on, but in order to do it, you're going to have to go through a bit of a dependency hell. So, this is what they call it. Basically, the startup notification functionality in Tint2 is dependent on the latest and greatest startup notification libraries, and in order to build that, that's dependent on certain Xorg libraries that we also don't have in our distribution, so we would have to build those too. I've done it before, but you have to like build like four separate other packages just to be able to turn on startup notification in Tint 2, and it's really not worth it. So yeah, if you value your time and your sanity, turn off startup notification on Tint 2. Okay, now in order to use the CMake system, let's check out the install file. This will have directions in it. Okay, yeah, we're gonna make a directory called build, change into that directory, and then run this this command, and that will do our that will compile the program for us. So make directory build, and change to that directory. I'm going to run this command, this CMake command. I'm going to change the install prefix from /usr to /usr/local, because that's where I like to install all of my software that I build from source code. Alright, that should do it. Let's see if it configures. Alright, it says configuring done. We can now run make. Again, I'm going to run it with the J2 option to do two jobs at once. Alright, looks like this build is going pretty quick, going pretty fast. Let's check out the PS3 real quick and see how it's doing on GCC. Oh, there it is. It's still building GCC. Yeah, it's going to be doing this for a very long time. Alright, might as well just let that continue. Okay, 100% done. Our Tint 2 panel is finished building, so now we can run sudo make install. Alrighty. Looks like that was successfully done. Now we've got our panel that will go at the bottom of our GUI desktop screen. So that's very good. Now we can back out of this directory because we're finished with the Tint 2 build. Now, move the Tint2 archive. I'm going to move that to installed, the installed directory, to help me keep track of what I've already built and what I still haven't built yet. I should probably do the same thing with the XDG menu that we just built previously. I forgot to move that to the installed directory. There we go. Okay, we're down to one more package that we're gonna build, one more application that we're gonna build for our little GUI desktop environment, and that's this one here, Nitrogen. So let's open up that archive. Let's see. There's the directory that was inside the archive, so let's check that out. Now, this archive does not contain a configure script. It contains one called Bootstrap, and that's the one that we're going to have to run first, and that will create our configure script for us. So let's run Bootstrap. Alrighty, Bootstrap is finished. Now we can run the configure script. As usual, we're going to set our first option to prefix and set that to /usr/local. And let's see, what else do we want to set? Let's see, this project does not have a whole lot of options. It's pretty simple. I'm going to disable NLS like I normally do. And here we can disable Xinorama again, because we don't have multiple monitors. And LD is our linker, so build with LD. I don't see any environment variables that I need to define that aren't already defined. So yeah, this should be a good configure script for us. I'm actually going to save this really quick into the ps3conf file. And I replaced the one that was there before, because I'm pretty sure that this configure command will be successful. Should be fine. Let's go ahead and run that. I should have all the dependencies required for Nitrogen. They should all already be installed, and it looks like the configure script was successful. Now we can run make. And again, I'm going to do 2 jobs at once. Yeah, Nitrogen is it's a very simple GUI program. Basically, all it does is sets the wallpaper, and you know, allows you to choose, like, what what directory you want to search for wallpapers in, and if you run it with the option restore, then it will automatically reapply whatever wallpaper was last, whatever wallpaper it put up last onto your system. It will just reapply that one, which comes in really handy for when you're starting up your graphical desktop. Yeah, you just set it so that it runs Nitrogen with the restore option, and that'll set your wallpaper every time you start your Openbox graphical desktop. This one's building a little bit slower. Guess I can check in on the GCC build, see how that's going. Well, yeah, it's still going. Hopefully we won't get like 22 hours into this build procedure and then like run into like a stupid error, like it's like it can't find a stupid like document conversion program or some ridiculous crap like that. Oh yeah, that happens sometimes. Generally not when you're building GCC. These GCC tarballs are very good at scanning your system and making sure that it contains everything that it needs for a successful build. Yeah, there's nothing worse than like getting like hours and hours and hours, or such a long time into a build procedure, and then having it fail just because you didn't have some stupid program installed, to convert XML documents or something. Alright, I'm going to switch back over to my laptop. Oh, goody gumdrops. Nitrogen is finished building. I'm going to run sudo make install. I can't remember if Nitrogen has any shared libraries. I don't think so, but just in case, I'm going to run sudo ldconfig anyway, because it can't hurt. Alright, that's all the packages that I generally build that are that pertain to my graphical desktop that I like to use. I can delete this directory. And I can move the Nitrogen files to my installed directory. Alright, I'm going to take a little break from building software now, and I'm going to show you my config files for my Openbox desktop, because I have to move them into the proper locations. So first off, let's get out of our source code directory. Now one of the config files, I think I've already got it in the place where it's supposed to be. This one here, xinitrc. If you want to copy a like a clean version, you know, unaltered version of xinitrc, you can find it on your system in /etc/x11/xinit. There it is. This is the original version of xinitrc, and you're going to want to copy that to your home directory. See, I copied it here. It's right there. I'll show you the contents of the original. There it is. Okay. Now, if you want to be able to run your Openbox window manager from the command line, what you would do is you would add a entry, add a line here that says exec. I'm gonna give the full path /usr/local/bin/openbox session, and that's where you would put that. And then you would rename this file as .xinitrc, so it's a dot file. Here's my one that I use. See, it's got the same line that I just showed you. This is going to allow you to run the Openbox window manager when you type the command start x. So let's see, that's one file that you need. Now I'm going to switch to .config directory. Oh, I don't think I have one. No, I don't. I'll have to create it. Okay, we're going to make a directory. Call it .config. And inside our .config directory, we're going to create two more directories. One called Openbox, and one called tint2. Okay, so these are the directories where you're going to put your config files for your Openbox window manager and your tint2 panel. Now, if you don't already have a tint2 RC file, backed up and saved like I do, then don't worry about your tint2 RC file. It will be automatically generated the first time that you run tint2, and that will be your default tint2 RC file, and it will be in this directory. I don't need to use the default layout, however, because I've got my own configured tint2 RC file that I like to use. So I'm going to copy it to that directory right now. cp-v. I've got all my dot files, all my config files are backed up on my NFS shared network shared directory under PlayStation, and it's going to be tint2. There it is, tint2 RC. I'm going to copy that to my tint2 directory. I'll show you the contents. Alright, this is what your tint2 panel configuration file looks like. It's pretty straightforward. For the most part, yeah, it's pretty obvious what all these settings do. If you don't want to configure your panel this way by editing this file, this text file, that's fine. You don't have to do that. When we built the tint2 panel, we also built the tint2 RC, or the tint2 configure program. So yeah, we're going to be able to run that and configure the tint2 panel that way. And it's graphical program. It's very easy to use. Now, last we have Openbox, our Openbox config files. If you want to, let's see, if you want to access the default config files for Openbox, they might not be installed on my system. I think they would usually be in etc/etc/xdg. Yeah. Yeah, I don't have an Openbox directory here because I don't have the distributions Openbox file, the application, the one that comes with Fedora 12 in the repos. I don't have that installed on my system at the moment. I've only got the one that I built. But just for demonstration purposes, let me go ahead and install the distributions Openbox, because that will come with, or that should come with the default config files, and I'll be able to show them to you. So we're gonna install Openbox. So now I know what you're thinking. You're thinking, dude, you're gonna have two different versions of Openbox installed on your system. How do you know which one you're running? You know, how do you control, you know, which one you're gonna be using? That's very simple, actually. You have to configure your path environment variable, which I will show you after Openbox is finished installing onto the system. And let me check out that directory again. list the contents of /etc/xdg. And yep, there it is. Now there's a directory called Openbox. So let me show you the contents of that. There's 3 files here. These are your configuration files for Openbox, and if you want, if you don't have your own config files like already, all ready to go, like I have, then you're gonna want to copy the contents of this directory, copy these 3 files, copy them over to your Openbox your Openbox directory under your .config directory, kind of like this. There. Now you've got copies of those configuration files here in your Openbox, in the directory that matters. And let me show you one of them. Here's the original menu.xml file. This is the file that defines your the menu that pops up when you right click on the desktop, and it's pretty self-explanatory. You can basically just follow the examples that are already here. So yeah, basically just follow the examples that are already here, and you'll be able to build up your own customized right-click menu, and you can put any programs on there that you want. Now I mentioned that in my menu I have an auto-generator script, well, an auto-generator program that generates part of my menu for me. Let me show you how I implement that. I'm actually going to delete these files because I've got my own copies of them that I'm going to use. And let's see, yes, I've got those in /media/NFS/PlayStation/Openbox. They're in there. Copy them to my current location. Okay. See, here's my menu file. This is my customized menu file. Menu.xml. And yeah, these are the items that you're gonna see on my right-click menu when I boot into the Openbox GUI. I've got a power off command here, a reboot command. I can also run, I put VLC and XChat, my IRC client, on there. This one here, Logisim, that's a that's like a electronics design and learning utility. Here's my Eclipse. That's a IDE, an integrated development environment. And up here towards the top, yeah, right here. This this particular menu item, or this particular line, actually move that. There we go. That's better. This is what generates my applications menu. You can see that there's a option here called execute. This option points to my Openbox XDG menu program that I built, and I put in /usr/local/libexec, and you execute the program Openbox XDG menu with this argument here. And yeah, what that does is it searches through all of your application files that are installed when you install a graphical program, and it reads those files, and it gets the information for all of the all of the applications that you can run, and it generates a basically it generates a string that it feeds to the Openbox menu system, and it automatically populates a section of the menu with pretty much all the GUI programs that are installed on your system. It misses some of them, but anything that it misses, you can just add manually. I'll show you. You'll see what I'm talking about. Let's see. Save changes. Yeah. Your rc.xml file. This is your settings for Openbox, the window manager. This file controls how your windows behave, and how you can run you can run certain programs by creating key bindings. Here, I'll show you. Go down far enough. Yeah, here's all the key bindings. This is where you can define how to close windows, move windows, iconify, maximize. This is where you set up your your hotkeys, and down here we've got key bindings for running applications. So here, when I type in Control Alt T, right here, that's going to execute my GNOME terminal program. So Control Alt T starts a terminal. Control Alt M starts Mozilla or Firefox. I've got Control Alt C runs my calculator. That's really useful. Control Alt V runs Pavu control. That's my volume control. Yeah, so you can set up your file however you prefer, and add your own applications to your hotkeys section. Let's check out my auto start. let's see. I can actually get rid of this line, xcomp mgr. That's not available anymore in Fedora. I'm running Fedora 38 now, and xcomp mgr, that's not in the it's not in the repositories anymore. That's a compositor. It's like an old compositor. I can actually change that to PyCom because that's the one that's available from the Fedora repos now. I'm going to leave it commented out though because I generally don't use a compositor on my PS3. I'm not going to say that it slows down the system or makes it run sluggish or anything, but you know, it's just extra overhead that I don't really require on the PS3. It's, you know, just to make my terminal like see-through. You know, that's cool and everything. That's fancy, but you know, the PS3's you know, got better things to do than make Windows see-through. And let's see. I run numlock X with the on option. It's going to turn on my numlock. And get rid of that pulse audio line. I'm going to leave that last one commented out too. I'm going to comment out nitrogen. So what that means is when I open up my Openbox desktop for the first time, this nitrogen program is not going to run because it's run with the option to restore the previous wallpaper to the desktop. But since I'm running Openbox basically for the first time on my system, there is no previous wallpaper for it to restore. So yeah, there's no reason to run nitrogen at the moment. We'll run it manually and set our wallpaper that way. Alright, that's good for auto start. Well, that's about it for all my config files, I believe. I don't think I'm forgetting anything. So let's go ahead and start our GUI desktop that we just built from the source code and see how it looks. Actually gonna log out of the PS3. Close up that terminal. Okay. Switch back over to the PlayStation 3. HDMI input. There we are. Yeah, it's still looking at the TTY2. And our GCC is still building. So that's lovely. All right, I'm gonna switch back to my main TTY1. It's this one. Oh, in case you're wondering how I do that, if you didn't know, Linux computers, they start these things called virtual consoles, and that's kind of like what we're looking at right now. And this is Virtual Console TTY1. There's actually like 5 others, and you can access them by hitting Alt F2 like this. That'll bring up TTY2. and then Alt F3 brings up TTY3. There's 4, there's 5, there's 6. Yeah, you've got access to like all these virtual consoles in Linux, and a lot of people don't even realize that that this is like that. Anyway, I'm gonna switch back to 1 because this is where we're gonna run our GUI desktop from, and log in. Okay. Now to start our GUI desktop, should just be able to start it by running start X like this. Okay. Very good. There we go. Yeah, my system's running. I forgot my system's running a little bit sluggish right now because I'm building the GCC toolchain on my other console. But there you have it. This is the Openbox window manager desktop, and that panel that you see at the bottom, that's Tint 2. That's what we built. I can show you our right-click menu. There it is. Now this is the menu that's defined by your menu.xml file. And here is the applications section. This is the section that's auto-generated by the program Openbox XTG menu that we built. See? It automatically generates these menu entries, you know, as you access them on the fly. Without this program, we would have to add all these programs to our menu manually, and that would be horrible. That would be not worth it. A major pain in the ass. Let's run nitrogen and set a wallpaper. There we are. That's nitrogen. Actually, I just remembered all of my wallpapers are on my NFS computer. Alright, so I'm gonna have to copy them over. Okay. Get our terminal open here. Oh, what an ugly terminal. I have to fix that. Really quick, I'm gonna copy over my my background, my wallpapers folder. Okay, I copied over some wallpapers. Make this a little bit bigger. I'm gonna change automatic to centered because they're all 1920 by 1080. I'm going to set my preferences and add the directory that I just copied. It'll be under pictures, 1080. Alright, there's all my wallpapers. And let's see. We'll pick a nice PlayStation wallpaper. How about Lollipop Chainsaw? See, now that I've applied a wallpaper to my desktop, now what I'm going to do is I'm going to edit my auto start file for Openbox. I'm going to uncomment my nitrogen command. So yeah, now what this means is that next time we start Openbox, it will automatically run nitrogen, and nitrogen will restore whatever wallpaper it put there previously. So that'll work now. And I've got to do something about this terminal. This is hideous. Let's fix that really quick. Okay, yeah, there's a couple settings that I like to set in my GNOME terminal. Make the font a little bit bigger. Let's see, title and command. What this command does with this, what I just typed in, this will set the term variable in this terminal, set it to xterm -256 color, which is a good setting to use. I'm gonna make it green on black. There, that's better. Set it to transparent. Add some scroll back lines. Okay, now I've got my terminal all set up the way that I like. Anyway, well, that's probably a good place to leave it for this video. So now, if you've been following along and paying attention, now you know how to build your own graphical desktop GUI desktop environment using Openbox, Tint 2, Openbox XDG menu, and also Nitrogen. All of which you can also install from the Fedora repositories, but I find that when you build your software yourself and you optimize it for your own platform and your own use case, I find that to be superior way of doing your computing. Anyway, so like and subscribe if you haven't done that. And stay tuned for more awesome PlayStation 3 Linux content and content about the Cell Broadband engine and PS3 development. Alright, thank you for watching my Linux show. Have a good day.